Guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at question 10 from the 2021 paper 1 multiple choice exam for the math methods external for the QCAA syllabus. Now you would have noticed I've started splitting off all the questions into separate videos. This is pretty much to give you a bit more variety, that way you don't have to watch the full exam video to find like the answer to one question. You can just go straight to that question. But you will still have access to that full exam. That link is in the description below. There's also an exam bundle linked in the description below. So it's a practice external exam. It's about this. I think it's actually the same size as an external exam, maybe a little bit longer, but pretty much it's set up exactly like an external exam. You've got a short response, you've got a multiple choice section, you've got a calc and non-calc section. Okay, it's about 40 pages long. It comes with full work solutions. And it comes with full work solutions for the multiple choice as well, okay? Which I believe these other external exams don't have. So yeah, if you want to check that out, link is in the description below. But otherwise, let's get straight into question 10. So question 10. The handspans of teenagers are approximately normally distributed with a mean of 15 centimeters and a standard deviation of 2 centimeters. Which of the following groups is expected to be the largest? So straight away we should know what topic this is. This is a normal distribution, okay? And they even said it in the question here, okay? So here with a normal distribution, what we should probably know are the percentages, okay? Now first of all, I should probably draw the normal distribution a bit better. It's like a bell curve like this, okay? So the average is in the direct center if it's normally distributed, which is 15 centimeters, okay? The standard deviation is your measure of spread, okay? So if you are one standard deviation on either side of a normal distribution, so for example, since the standard deviation is 2 centimeters, if you're between 13 centimeters and 17 centimeters, that's 68% of the data, okay? Now, where I got 13 and 17 from, I added and subtracted the standard deviation on either side of it, okay? So if you're one standard deviation away from the mean on either side, that's 68% of the data. If you're 2 standard deviations away from the mean, that's 95% of the data. And then finally, if you're 3 standard deviations away, which is very unlikely, you're about 99% of the data, okay? So here, what they're doing is a comparison here in terms of like numbers, and we need to work out roughly where those guys sit. So here, let's start with the first one here, okay? So between 7 and 11, okay? Well, 7 and 11 would be about here. So here, that would be, so if you went another standard deviation here, that would take you to 11, and then you would have to go 2 more standard deviations this way. So if you're between 7 and 11, that would be around here. Now, I don't know about you, but that's a very small area there. So I would say a very unlikely, so I would say that's pretty small. So I'm just going to put small here because who knows, maybe the other ones are even smaller. Let's check out the next one. So here, between 11 and 15. Now 11 is here and 15 is up there. So this area straight away is a lot bigger than that little red area. So I'm going to say this is probably not the answer straight away. Okay. But who knows? If we find something bigger than this one, then maybe, yeah. 13 and 17. 13 and 17. So that would be between here and here. Now that is a lot bigger than that one there. So that would probably be the biggest at the moment, but who knows? We'll check. So at the moment, that one's in the lead. And then the final one, between 17 and 21. So 17 and 21 would be this area up there. So the largest area is C, between 13 and 17. And the reason why we know this is actually just from our drawing here, because the further you go away from the standard deviation, the smaller that percentage gets on either side. The biggest bulk percentage is the closer you are to the mean, okay? Now, if you got that question wrong, you need to study normal distributions a bit better. You also need to know those percentages, okay? This is something you should know straight off the top of your head when you're studying this topic here, okay? You should also know this formula for your Z-score if it does pop as well. Now, it didn't pop up in this question, but it could pop up, okay? Know these, know that, and you should be fine with a question like this, okay? I wouldn't say this is a hard question at all, but this would actually stump a lot of people if they don't have a good understanding of what it looks like. Anyway, so the full exam is linked in the description below, and my exam bundle pack is also linked in the description below, so that's an extra resource if you run out of past papers. But otherwise, I will see you in the next video. If you have any questions, comment below, and I'll try my best to answer it. But otherwise, see you in the next video.